Lecture DO2, Principles of Unitized Facade Systems, in comparison to stick systems, unitized systems as an entire frame. And we follow the same outline of the lecture, the positioning of the facade, the loads of the facade, tolerant movements and how to deal with that, the brackets which do deal with the tolerance and movement, the water tightness and result of the water tightness, the drainage of this system, the position of unitized facade. As unitized facades are prefab units which we need to install on site, we would have difficulties to get this into the structure, which consequences that we mainly are using unitized facades in front of the main structure, the primary structure, and not within the system. So an exoskeleton situation is not that much expected for unitized facade systems. Unitized facade means it's an entire frame which contains all components which we need for the facade. So the inner layer of insulated glass units with an openable window, the outer layer in the case of a double facades with a single layer, all the louvers, all the sun protection devices being brought in position are installed in the factory into these unitized facades, and then they are brought on site to be installed. A more detailed view of such a unitized facade as a double facade, we see an outer layer, we see an inner insulation glass unit layer, we see the openable window, and we also see 3 layers of sealant, which we will investigate deeper in the later part of this lecture. Then this unitized facade is brought on site, and transport is one of the key aspects of unitized facade. It's done prefab, then transported, and obviously dimension of possible dimension of transport is one of the key aspects. So they have to fit into these racks, they have to fit on a truck, and then being transported through the country to the construction site. So the dimension possible to be transported, that defines the size of the unit. Then they're installed. It's rather simple done. It's one person at the crane, one person at the bottom, hooking all the units onto the crane, and then they're brought into position. And then there are 2 or 3 people taking these units in position, fixing them, sealing them, unhooking them, and then the next unit comes into a position, which obviously results in a very fast process of installing, because pre-assembly is already done, and then we only install these prefab units, and by that are rather fast in getting this done. It does not need to be a rectangular unit. It could be also some kind of freeform shaped unit, depending on the design, which is done. As we can see here in this sample. This is the units at the rack being prepared for installation, and we see already the brackets taking these units in position, allowing them to be hooked on top of the floor plate at the system. This is how it looks like when it is finished. Nice hotel in Copenhagen. Tolerances and movement. As facades are supposed to not take main loads, structural loads out of the building, but being brought in position in front of the main structure, these facades are hooked onto the main structure, being brought in position in a way that they deliver their own dead loads to the main structure, but don't take dead loads out of the main structure. Also, functional loads are only delivered, and nothing is taken out of the main structure as a system. We normally have them hung, so a unitized facade normally is hung in position, which means there's a top point which is entirely fixed, allows 2 directions to be fixed, and then there's a bottom point which is horizontal fixed, but vertical allows movement. So in the case of movement of the building or the facade, there's no interaction which then would cause damage to the facade by being compressed or put under additional loads in the system. These brackets have to do are allow the movement in the system, and B, in the first step, taking the tolerances of the main structure versus the facades. Main structures, in this case concrete, is built with a tolerances of 2 to 5 centimeter versus the facade, which is built with a tolerances of 2 to 5 millimeter. So we have to make an adjustment between the concrete floor slab and the facade, which is rather precisely in position. So somewhere there's a concrete and the facade, which is quite precise, that needs to be adjusted in all 3 directions. And that's what these details do. they allow a horizontal and a vertical positioning in this direction, and they allow a horizontal positioning in this direction as well. These are systems. We don't design them ourselves. We don't have to design them ourselves. They're normally given by the system supplier. We can adjust these systems, and if it is getting too complex, we may have to reinvent and redevelop these systems. For example, this one, which is a different bracket, which takes these functionalities. It actually takes at the bottom part all directions of tolerances. For vertical tolerance at the bottom part, it's taking all the three directions as well. And you even see that there's a slider at the top part which allows a movement of the hanging facade on top of it to secure that there's no interaction between any movement of the building and any movement of the facade, to prevent unexpected forces within this facade. These brackets are defined like this. We have this horizontal bracket which allows in all directions the movement, this direction, the hook which needs to be adjusted, and the possibility to adjust it in this direction as one bracket system. This is exactly what I just showed, the bracket which we used, or which is used for this system as a set. And then there's the need of connecting these unitized facades. So we have this one unitized facade, we have the next one, they're hooked on top of a floor slab, and then the next one has to stay on top of it. And the alternative in having a movable bracket at this position is to have these spigots. Spigots are actually this type of aluminum profiles which allow that you have the one profile and the other one adjusted on top, which takes all the horizontal forces, but still allows a vertical movement by tolerance or movement of the building as a system. Different way of creating this connection between the different units on top of each other. Weather tightness. When we look at the unitized facade, and as I described, and then we have this one unit here, which is one part of the unit. We have the other unit here, which is the other part of the unit. The sealant of the glass has to happen, and the sealant between the unit has to happen. So the glass sealant, which is done here in this situation, outside, rain tight, inside, watertight as a system, which happens with gaskets being positioned and taking keeping the glass. Then the outer sealant, the outer watertight sealant, which is happening in this position, and then the inner watertight sealant, for the outside, which is happening at this position, and also solve the connection in the joint, and then the inner airtight sealant, which has to make sure that there's no humidity coming from the inside into this gasket system. We are using 3 layers, which is the typical setup which we nowadays use for prefab components. If it is now an aluminium profile system or if it is a concrete prefab component, these 3 layers are the typical ones being used. And this is how it looks like in reality when we look at it. This is the aluminium profile of the unitized facade. It actually carries the glass here as with a glass carrier layout. It's a structured glazing concept in this setup. Here we see the inner sealant, airtightness. Here we see the outer sealant, outer layer, rain tight, inner layer, rain tight. And if there's any humidity getting in here, it needs to be entirely drained to the outside as a system, which brings us to drainage. That means that in the case of any humidity in the cavity, the humidity needs to be drained out of the system, either via the element needs to be drained out of the unitized system. When we go back into this one, this device needs to drain in the vertical connection, where we have the vertical connection down to the bottom. It needs to drain any humidity to the bottom of the entire system as a drainage system. And by that, I stop this lecture with some literature and see you in the next one.